Async Rust is supposed to be fast. Thousands of tasks running concurrently, blazing performance, but one small mistake can completely destroy your async runtime. If you run CPU heavy work inside async tasks, your entire executor can stall. In this video, we're gonna learn uh, why CPU work blocks async runtimes and why this happens in Tokio and the correct way to fix it using spawn blocking. Async runtimes like Tokio work using a small pool of executor threads. These threads continuously poll futures. The rule of async is simple. Futures must never block the executor thread, but CPU heavy work does exactly that. To see this in action, we are going to create a CPU heavy task where it will append every numeric digit to our sum variable. So let's create that heavy task function and interval sum and loop around uh, loop and will return and will print our sum. So now we're going to use this our uh, CPU heavy task function inside our main.rs. So let's use focus point and call our function. Now also we in background we are going to run some another task also to see that our CPU heavy task is actually blocking. So wait, let's import this and duration also. We have created some background task which will print tick log every 500 milliseconds. So to confirm this, let's run our program. Sorry. Wait. Now you might be wondering that our CPU heavy task is actually not blocking. It's actually it's actually running parallelly, but because we have not mentioned that we have to use current thread runtime, so let's do that. Now if we run our program, uh, then our CPU heavy task will block our main thread. So as you can see, our CPU heavy task block our main thread. So to fix this, we are going to before fixing, let's try to understand what's going wrong. So CPU function runs directly inside the async task. Since Tokio executors run on a limited number of threads, this CPU loop occupies a thread for a long time. During that time, the runtime cannot poll other features. Think of Tokyo like a restaurant kitchen. The executor threads are chefs, features are dishes waiting to be prepared. If one chef starts doing a 3 hour cooking job, every other dish waits. That's exactly what CPU heavy work does. To fix this, we just only need to implement Tokyo spawn blocking in our just need to wrap Tokyo spawn blocking in this CPU heavy task. So let's wrap our spawn blocking Tokio function. Spawn blocking and we pass empty closure and we'll call our function and we'll await it. So now if we try to run our program, it will it will work as expected. So let's run our program. So as we can see, now our heavy CPU task function is not blocking our main thread, and our background task is running smoothly as expected. Spawn blocking moves the work to a separate blocking thread pool. This prevents CPU work from blocking the async executor. Tokio internally maintains two thread pools. First one is executor threads for async tasks, and second one is blocking threads for CPU heavy or blocking operations. Spawn blocking sends the work to the blocking pool. So think of async executor as a lightweight tasks, and for blocking pool, think of as a CPU heavy task. So you should use spawn blocking when doing cryptography, image processing, large JSON parsing, compression, CPU heavy algorithms. Otherwise, your async runtime becomes slower than synchronous code. If your application is mostly CPU bound, async may not even be the right model. Sometimes using parallel threads with Rayon can outperform your async completely. Async Rust is extremely powerful, but it only works if you respect one rule. Never block the executor. If you have CPU heavy task, move to the spawn blocking. Otherwise, your async runtime will silently lose performance.